Section 17.2 is graphing rational functions, and these take a while to do, but a lot of learning takes place meanwhile, so we really like this section as instructors. It helps you put a lot of things together of why did we learn this and that. So we're going to first analyze the graph of the rational function, and we're going to go through these steps step by step, factoring the numerator and denominator, looking for the domain. Then we're going to write R in lowest terms. So let's talk about what that means. When you had a fraction, if you had 12 over 8, you'd say, well, let me write 12 as 2 times 6, which is 2 times 3, and 8 as 2 times 2 times 2. And then I see I have matching factors here, so that's a 1, another pair of matching factors, so that's a 1. So then when I write it as 3 halves, this is in lowest terms. So if you have a polynomial in the numerator that factors to x plus 1 times x minus 2 times x plus 3, and a polynomial in the denominator that has matching factors with the one in the top, x plus 1 over x plus 1 is always 1, x minus 2 over x minus 2 is always 1, and so in lowest terms, and we should give this a different name because it's actually a different function, x plus 3 over x squared plus 4. Because remember we talked about that this will make a whole at x equal -1 and x equal 2. So this graph and the graph of R look exactly the same except where these two holes are. So then we're going to look for all the intercepts of the graph, x-intercepts and y-intercepts. Look for vertical asymptotes and or holes. We don't usually put very many graphs with holes for you to graph, but occasionally they'll come up. And then we're going to find any horizontal or oblique, or they're also called slant asymptotes. And then find any points where you intersect that slant asymptote or horizontal asymptote. And then we're going to graph the asymptotes and find out any more points that we need to figure out how to draw the graph. So let's look at A first. So we have g of x, and our first thing we need to do is factor the numerator and denominator. So I see I have a sum of cubes, so I'm going to have x and 1, x squared x and 1, same sign, opposite sign, always positive. And then in the denominator I have x times x plus 2. So I don't have any matching factors in the numerator and denominator, so this is in lowest terms. And then the domain is going to be x can't be 0 and x can't be -2. So that's step 1, is to factor the numerator and denominator and find the domain. And step 2 is write it in lowest terms. It already is. So then step 3 is find intercepts of the graph. So to find x-intercepts, you set y equals 0. So you say, when is this equal to 0? And it really doesn't matter what the denominator is. The denominator is never going to make the value of a fraction 0. In fact, you can multiply both sides by the denominator. So really the only thing you have to look at is when is the numerator 0. Well, when we factor a difference of cubes, this quadratic part is never factorable. You can check it if you like. So the numerator will be 0 when x plus 1 equals 0. So when x equals -1, so the x-intercept is -1, 0. So that's a point we know has to be on the graph. And then we also know the graph cannot cross the x-axis anywhere else. Or we would have found it doing this math. Okay, then we need to know y-intercepts, and you find those by setting x equal to 0, or you can call that r of 0. So, oh, I'm sorry, my function's name is g here. Lost the first page. So 0 plus 1 over 0, well, that never happens. So there's no y-intercept. The function is not defined when x is 0. So then we're at step 4, find any vertical asymptotes. So when you figured out the domain, really that's the same work. You just are saying now equal instead of don't equal. So when x equals 0 and x equals -2, you need to have vertical asymptotes. Okay, so let's go ahead and start making our graph. X equals 0 is the y-axis. That's always kind of hard to draw, but we'll label it as this is the vertical asymptote, x equals 0. And then we have x equals -2. So those are our two vertical asymptotes. And we can put our x-intercept on the graph is at -1, 0. Okay, so now we're going to look for any horizontal or oblique asymptotes. Well, g of x has degree 3 numerator and degree 2 denominator. So this is the case where you have a slant asymptote or an oblique asymptote. And so you have to do polynomial long division to figure out the equation of the slant asymptote. So we're going to have x cubed plus no x squareds and no x's plus 1 divided by x squared plus 2x. So we're going to have an x up here and an x cubed and a 2x squared. And we're going to subtract that. So subtraction of polynomials says add the opposite. So I'm going to have -2x squared. So then I'm going to have -2 in my quotient. Let me bring down my 0x and my 1. I'll have -2x squared minus 4x, and I'm going to subtract. So I'm going to have a remainder of 4x plus 1. So this function, x cubed plus 1 over x squared plus 2x, can be written as x minus 2 plus 4x plus 1 over x squared plus 2x. Well, this last piece, as x goes to infinity, this goes to 0. So let me give you a second to think about why that would be. Oh, I have x squareds on the bottom, so I'm dividing by a much bigger number. So as x gets really, really large, imagine it's like 4 million over 4 million squared, and that's getting closer and closer to 0. So g of x is getting closer and closer to, excuse me, y equals x minus 2 as x goes to infinity. So this is the oblique or slant asymptote. Okay, so we need to add that to our graph, y equals x minus 2. So it has a y-intercept of -2 and a slope of 1. So here is my oblique asymptote, y equals x minus 2. Okay, so now I had to figure out where my graph goes in here. Oh, I have another thing I need to do in step 5. It says, figure out if the graph of R ever intersects the asymptote. So we want to know, does r of x ever equal the equation of the line x minus 2? If it does, then there would be a point of intersection. If it doesn't, then there's not. So this is an important piece of information for us. So we want to know, does x cubed plus 1 divided by x squared plus 2x ever equal x minus 2? So we need to try to solve this. So we're going to multiply both sides by x squared plus 2x. And we want to know if x cubed plus 1 ever equals x cubed plus 2x squared minus 2x squared minus 4x. So subtracting x cubed from both sides, 2x squared minus 2x squared is 0. So I'll get 1 equals negative 4x. So it turns out that when x equals negative 1/4, g of x, sorry, this is g of x intersects the oblique asymptote. So when x is negative 1/4, there's a point right here where the graph intersects the oblique asymptote. So it is possible for a graph to touch or cross horizontal and oblique asymptotes, but not vertical asymptotes. Okay, so now we have this grid and it's divided up into vertical strips. If we think about the domain, we have from negative infinity to negative 2, that's one section of the graph. Then from negative 2 to negative 1, that's another piece. Then from negative 1 to 0 is another section of the graph. And then from negative 1 up. So now we need to figure out where this graph goes. So in the leftmost section, where x is coming from negative infinity and coming up to negative 2, we have to figure out where the graph could go. Well, it really only has two choices. It has to approach the vertical asymptote, and it has to approach the slant asymptote. So one way it could go would be like this. The problem with that is, I just crossed the the horizontal axis, and I know I can't do that. So the graph must be down here, because this is the only other choice left. Okay, so that's the first piece of our graph. Now between negative 2 and negative 1, I either have to be approaching the vertical asymptote coming up from below, O, but then I crossed the oblique asymptote at a place where I can't. So I must be coming from above to the x-intercept. And then I have to go down through this point where I cross the slant asymptote and then approach the vertical asymptote. Now again, I only have two choices really. So one choice is this shape, and the other choice would be this shape. But see how the green one intersects the x-axis, so I know it can't possibly be the green one. So I only wanted to take off this guy. There we go. So it has to be the blue shape. So I have to approach this vertical asymptote and approach this vertical asymptote. And then feel free to use Desmos to check your result. And that's the graph of our function. Okay, so I'm going to do one more example in another video.